Hello again, fourth graders, and welcome back to Math Workshop. Today's lesson is called 3.4, which is all about equivalent fractions. Now, if you remember way back from lesson 3.1 last week, we were talking about the idea of equal sharing or equivalence between fractions, meaning we're trying to find fractions that are worth the same amount or that have the same value, but that are called different names. That means that the number on the bottom, the denominator, might be different because it's breaking one whole thing into a variety of different pieces. And the numerator will also be different because, of course, if the bottom number changes, then the top number changes because more parts will need to be shaded in order to be an equivalent fraction with the other number of parts. So it really just depends on how we're breaking fractions up. You also may remember that when we were talking about this idea of equal sharing and equivalence, I gave you a trick in order to super quickly find equivalence between fractions. So today we're actually going to talk a little bit about that rule called the equivalent fractions rule. So the equivalent fractions rule is used to rename any fraction in the whole entire world to a different name, but it's still equivalent. So it's kind of like we talked yesterday or in our last lesson about how you have a full name, but sometimes you might have a nickname. It still means you and it still represents you as a person. It's just a different way of saying your name. So when we are trying to find equivalent fractions, one of the ways that we can do that is by using tools like a number line or some fraction circles. But if we don't have those tools available to us, there's also a really fast, easy, simple way that we can find equivalence between fractions to call them different names. So here's a quick reminder of our terms. Remember, we know that a fraction has a numerator, the number on top of the fraction, and that represents how many pieces are shaded in or how many pieces there are included. And the denominator is the number on the bottom of the fraction, and it represents the number of parts possible to create the whole thing. So one of the rules that we can follow to be able to find equivalence super quickly is if the numerator and the denominator are both multiplied by the same number, then the fractions are equivalent. So here is what that looks like. Here's the fraction 1/2. So if I want to find out if it is equivalent to 3/6, I want to find out if they're equal. So I'm going to want to use either a less than, a greater than, or an equal to symbol to show equivalence or inequivalence between these two fractions. So the rule is if I can multiply the same number times the numerator and the denominator, then this fraction is equal to this one. So I asked myself, okay, what do I do to get from 1 to 3? What do I multiply? 1 times what equals 3? Okay, the rule is 1 times 3 equals 3. So now I know that this fraction will be equivalent if I can do the same thing to the denominator. So let's see. To get from 2 to 6, can I do the same thing? 2 times 3 equals 6. Is that true? Yes. So that means that 1/2 is equal to 3/6. 1/2 is equivalent to 3/6. Let's try another one. Here's two fractions, 4/8 and 16/32. 16/32, I suppose. Okay, the rule is, first let's find out, how do I get from 4 to 16? What do I do? 4 times what equals 16? 4, 8, 12. Okay, so it's 4. 4 times 4 equals 16. That means that if I can do to the bottom what I did to the top, if I can multiply this denominator 8 times 4 and that will get 32, then these are equivalent fractions. So let's see if it's true. 8 times 4 equals 32. 8, 16, 24, 32. Yep. So that means 4/8 is equivalent to 16/32, I suppose is how you would say it. So did you see that whatever I do to the bottom, I have to do to the top? The rule is if I can multiply the whole entire fraction, the numerator and the denominator, by the same number, then the two fractions that I'm comparing are equivalent. Let's try one more. 9/18 compared to 18/36. Okay, let's see. What do I have to do to go from 9 to 18? 9 times what equals 18? 9 times 2 equals 18. So if it's true, 18 times 2, whatever I do to the top, I have to do to the bottom. If that's true, 18 times 2 equals 36. Yep. So 9/18 is equivalent to or equal to 18/36. So if I can, whatever I do to the bottom, I have to be able to do to the top. If I can do that and still end up with equal numbers, then the two fractions are equivalent. Let's take a look at this one. 4/12 and 8/16. Remember, we're comparing. We're trying to find if one is equal than, greater than, or less than, right? So we're always trying to compare. One is bigger, one is smaller, or they're equivalent. So let's see what we have to do. Remember our rule, whatever we do to the bottom, we have to do to the top. So how do I get from 4 to 8? To get from 4 to 8, I skip count 2 times. 4 times 2 equals 8. Okay, so the rule is whatever I do to the bottom, I have to be able to do to the top. Is it true that 12 times 2 equals 16? No way. 12 times 2 equals 24. This is not equal. So that means that 4/12 is not equal, we say unequal to 8/16. And we show that by putting an equal sign with a slash through it, because they are not equal to each other. If we were to compare these a different way, 4/12 and 8/16, just because the number on the bottom looks bigger doesn't mean it's the bigger fraction. Actually, it's that rule of opposites in math, right? If I have 12 pieces possible out of my pizza and I've shaded in 4 of them, then I have to take a look and see if that's equivalent to 8 pieces out of 16. And we know that that's not true because this is kind of like 1/3 and this is like 1/2. So they are unequal to each other. 8/16 is actually bigger than 4/12 because if I only have 8 pieces of pizza finished out of 16, I've eaten half the pizza. But if I have 12 pieces of pizza and I eat 4 of them, I haven't eaten half, so they're not equal. 8/16 is actually bigger. So we use that quick rule. Whatever we do to the bottom, we have to do to the top. If that's true, and we can do that, then the fractions that we're looking at are equivalent. So today you're going to work on journal page 77. You're going to do journal page 77, and you're going to do all of them on page 77. On page 78, you're only going to do number 2. On page 79, you're only going to do numbers 1 and number 3. And the math boxes on page 80, you're only going to do number 1 and number 5. So be sure that you double check that on Google Classroom. You do not want to do any work extra. You don't want to do more than you're supposed to. Remember that you should do the journal pages first and then check them and see how you're doing. If you're not doing so hot, then you're going to probably want to reach out and see how we can fix it together, what we can clear up, what misconceptions or misunderstandings we can clarify. If you're able to see right away what you're doing wrong, then you can go ahead and go back and try and fix it. Before you do the math boxes, though, head on over to the exit ticket and show Ms. Jungle your level of confidence and comprehension on the concept, and then go back and do your math boxes after. Okay, so as you head off, remember you can always hit me up in the chat if you want to do some examples together, or you can send me a message and email, and I'll be sure to put you on my list. Have fun, practicing 3.4, finding equivalence rule. Off you go, fourth graders.